So we're on 3.4 of your chemistry book, and we're going to be talking about percent composition and formulas, okay? So if we think about percent, at first this first part just says the law of definite composition. A given compound will always have the same mass or ratio or mass percent no matter what its origin is. Remember, so that was actually one of your questions on your test last time. So basically what that's saying is that a certain composition is always going to have the same ratio between the different particles in mass. And so we'll see that in just a minute when we figure it out. Just remember, like, if there's carbon and hydrogen and oxygen and they all have different numbers of mass, that ratio will always be the same in every atom of that, or every molecule of that. So it's the definite ratio, a law of definite composition. A given compound will always have the same mass ratio or mass percent no matter what its origin is. And this is what helps identify the compound. The percent composition is what percent composing each of those different molecules, or I should say atoms, are in the molecule. So we can find this percent of the total mass by each element, and this is what we're going to talk about. But first, they're just talking about percent, so you guys know how to figure out percent. So I'm not going to go in here, but if you have a room full of girls and boys, and you divide it into girls and boys, we'd count how many there was and then find out the percent there was compared to boys and girls. So you'd say take the number of girls divided by the total number of students, and you find that there was basically 12, say there's 12 girls and there's 26 students, and you can use that on your calculator and you times that time 100%, and you'll say, basically figure out that 46% are girls. Now the boys have 14 out of 26, and so you times that, you turn this into a decimal and times that, you'll get 54%. It's the same way we're going to do with each element in a compound. So let's look. Here's the example. Find the percent of the composition here of carbon, hydrogen, and oxygen. Okay? So as we look into that, we'll find out basically what you have to do is you find out what mass it is. And to find out mass, you have to put it in grams per moles, remember? So we have to figure that out. So maybe if you could zoom in here, can you see this pretty well? Okay. So here is, we find out that there are, if you look on the periodic table, you'll find out it's 12.01, and that would be basically, as you figure out the grams per mole, so that would be the grams per mole. So you just find out the atomic weight on that, and you'll find it that the weight on each molecule is in units, and we'll change that, of course. We figured how to do that in the last part of the chapter. So here we have 2 times 12.01, because how many carbons are there? 2. 2 times 12.01, and that equals 24.02. And then we find how much hydrogen. Well, we have hydrogen. How many do we have? We have 5 hydrogen, and we have another hydrogen. So we have 6 hydrogen in there. So 6 times, and we know that the grams per mole is 1.008, because that's the mass, and you change it to grams per mole, same as grams per mole. And you change that, and you multiply those two together, and you get 6.048. So that's the total of hydrogen. Now you look at the last one, which we're going to look at oxygen. There's only 1 oxygen in there, so oxygen we know is 16.00 grams per mole. And so that equals 16. So now we have all of these 3 grams per mole. So now we have to take and add them all together. And what do we get? We get 46.068. We just added these all together, which is approximately, you want to do 2 sig figs, so it's not a big, huge number. So it's basically you round this to 46.07. are the same sig figs. I mean, there's 1, 2, 3, 4 sig figs there. So anyway, 46.07. So now to find the percent, it's not going to be, you just do these just as you go. You're going to find the percent of each one of those. So to find the percent there, what you're going to do is basically take the mass in C, which we have the mass here, right? 24.02, we put it there, and just divide it by the total mass, the same way we did as the girls and the boys and how many the total were. And so you divide it by the total mass, which is 46.07. So get your calculator out. They already did it for you here. So 24.02 divided by 46.07, and then you're going to times it by 100% so you can get it in percent. So anyway, you basically got, if you divide this out, you're going to get 52.14%, right? And that's going to be the percent of carbon. 52% is going to be carbon. We do the same thing for hydrogen. So hydrogen, of course, we have this number up here. This is how much we have of hydrogen, which is 6.048. And then we divide that by the total, which is 46.07, times the 100%, which equals 13.13%. So this would be 13.13%. When you turn it to a decimal, then you'll turn the decimal into percent. And so now we have the same thing for oxygen. We only have 16 of oxygen. Divide that by 46.07 times 100, we get 34.73%. So we have 52.14, 13.13%, and 34. And does this add up to 100? And if you check to see, and as you add it up, it has to be close to 100 because you've been rounding in the rounding steps. So let's go up and see right here at the bottom. So you check to see if each one of these percents comes to 100%. When they added it all up, yes, it was 100%. So each one, so we know how much. There's going to be 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen. And that's going by weight. Because before we're going by the weight, which is, remember, gram per mole, because we can't really weigh out a single atom, but we put it into grams per moles, and we go by moles, which is the avocado number, remember. So that's how we do those to find the molar mass compound. We're finding the percent of composition of all the different parts of ethanol there, right here at the top, CHOH. Okay. So it wasn't too hard. We just go step by step. So this is another to find percent. So, or we're going to go through the percent. You have a 1.261 gram sample of caffeine that contains 0.624 grams carbon, 0.065 grams hydrogen, and 0.364 grams nitrogen, and then we have oxygen 0.208. So now we want to find the percent in the composition of caffeine. So in this example, we do not know the formula of the caffeine, but the experimental data tells us that the mass of the compound is this. So we know the mass now is 1.261 grams. So how do we find this when we have the grams? So we're going to find the mass of C. So we take the mass of C, which is carbon. So we take 0.065, okay, with a mass, 0.624, and then we divide it by the total mass, which was 1.2. So you just divide it by grams. When you divide this on your calculator and you times it by 100%, you're going to get 49.5% carbon. We do the same thing for the grams of hydrogen. Take this number, put it down here, and then divide it by the total number up here. And then as we're dividing it by the total number by percent, and then we'll get 5.2% hydrogen. Same thing we do for the nitrogen. The nitrogen up here is 0.364. So 0.364 divided by 1.261, which is that number. Again, it's the mass of the compound, and we get 28.9% nitrogen. and the oxygen again, we're going to divide 0.208 grams oxygen divided by the total. This is actually an easy one because we don't even have to change it to moles or anything here. And so we divide that 16.5%. So we have 49.5% carbon, 5.2% hydrogen, 28.9, and 16.5 oxygen. So, and then we add these up together, we check the sums, and we ignore the rounding error and find out the sig figs are all looked fine. And as we put it together, we'll find it comes to approximately 100%. Okay, another example here of how we're going to do this here. So we have, find the empirical formula of caffeine. Well, let's find out. Let's go back here. I think we missed something on the empirical formula, didn't we? Right here. So let's talk about this so we can know what our empirical formula is. So an empirical formula is the simplest ratio of atoms present. Remember we had that. A molecular formula is based on the actual model of it. And empirical formula a lot of times is used with ions, because ions come in big groups and that are just clumped together in so many groups instead of just having one molecule to one molecule a lot of times, but the ratio is the same. But anyway, empirical formula is just giving that simplest ratio. So, and we learned that by using percent composition data or composition by mass data, you may determine the empirical formula of a compound. So basically, they're going to give you the mass data, and then you're going to make the formula from it, or you're going to find out what the formula is. And so they have like a 4-step method here, and you can go by the method pretty, just follow each step, or, there's actually a simpler way to do it, and we'll look into that. But to go by the formula first is the easiest way to do in the steps. Let's look at what the steps are going to be. First of all, based on the calculation on exactly 100 grams of the sample to simplify the calculation. So you're going to go by percentage, so you have exactly 100 grams. So you have to make sure you have that exactly that 100 grams. We'll see that too. And then you're going to convert the mass of each to moles of atoms for each, like we did before. So we're going to have to look up the mass by the atomic weight, or the mass weight, and find out how much each is. So like a 16 for a gram mole of oxygen. So you're going to turn it to there. Up here at the top, let's move it up here. You're going to divide the moles of each step by the smallest mole. So you're going to take the smallest number and divide it. If the quotients are not whole numbers, multiply each by the integers to make them whole numbers, because you want them whole numbers, because you're not going to have a part of an atom here. You're going to have you're going to make a formula, and you can't have you have to have whole numbers. So you express the empirical flow by using the whole numbers obtained in this. So you put the whole thing together, and we'll see how to do this. So for some compounds, the molecular formula based on the actual molecule is a multiple of the empirical formula. So it could be a multiple, so you have a ratio of 1 to 2. Well, you can have that ratio turn to 2 to 4 or 3 to 6, or, so that ratio could be different for the molecular formula as it is with this. Remember, the empirical formula is the simplest formula. So then you calculate the molar mass based on the empirical formula and divide it. And you'll see how to do that. So it's hard for them to explain this to you and me to explain it to you without just doing it. So let's do it. Here's the example. So you want to find the empirical formula of caffeine. If the caffeine is 49.47% carbon, 5.19% hydrogen, and 28.86% nitrogen, and 16.48 oxygen. So we're just doing the opposite as we did in the other part, but this is how we do it. First, you're going to change these to grams instead of our percent from 100 grams. So if you have 100 grams if you have 100 grams of something, what percent would it be? So it's easy to do that, because really 49.47% would be 49.47 grams. 51.19% would be 5.19 grams, because that's how much would be in 100 grams. And 28.86 would be 28.6 grams. So you're just changing these, basically taking off the percentage and changing them to grams in 100 grams, within 100 grams. So basically doing that. It's pretty easy. That's an easy step. On to the next step here. It says convert these masses to moles using molar masses. Okay, this is what we had to do before. So we have 49.47 grams of carbon here. And so what is the molar mass? We looked it up. It's 12.01 grams per mole of carbon. And so we divided that out. Get your calculators. They divide it out on the calculator, and it comes to 4.119 mole of carbon. We do the same thing for hydrogen. We looked up hydrogen. It's 1.008 grams per molar. Divide this number here, divide it by the molar mass, and you get 5.150 moles of hydrogen. So we do it again with the nitrogen. 28.86 divided by 14.01, and we get 2.060 moles of nitrogen. Same thing with oxygen, 6.48 divided by 16, we get 1.30 moles of oxygen. You could use a calculator just dividing by the moles, so on each one of those four different CHN0, so each one. So those are the percentages. Now we go up the top here. We divide each mole by the amount of the smallest value. What's the smallest value? 1.030. I'm not sure why they picked the smallest value, but I guess the smallest value would give you the best number, the best the closest number to the ratio, right? So anyway, so if we divide 4.19 by 1.03, we get 4. So just close to 4. 5.15 divided by 1. Actually, it's almost like 5 divided by 1 is 5. 2 divided by 1 is 2. 1 divided by 1 is 1. So we have 4, 5, 2, and 1. Since all the values are whole numbers to 2 sig fig, so basically we have each one of these whole numbers we can use them and write the formula. So how do we write the formula? Well, we can put down CHN2. Well, C is 4, so put a little script there, 4. Hydrogen is 5. Nitrogen is 2 with a little 2 by it. And oxygen is 0. Okay? So then we can calculate the molar mass of the empirical formula. Well, basically, what we do here, step 5, so we have the empirical formula, but maybe we want to have a molecular formula. Maybe these are going to be multiples in some way. So what we do is we add up all of these molar masses up here that we had. The molar masses that we got down here. So we add them all up, 48, 5, 28, 16. We get 97.10 grams per mole when we added them all up. So we added up all these here, all of our molar masses. Now we divide the actual molar mass by the empirical formula. So we calculate the molar mass of the empirical formula, which we did right here. And so now we know what we want to know here is B here, if the actual molar mass of caffeine is 194. So we just divide 194 by the 97, which we get approximately 2. So now we know it's the regular formula is going to be 2 times this. So C4 would be C8, H5 would be H10, N2 would be N4, and O would be O2. So that would be our formula. The reason we found this out because we know that this is going to be twice as much, so 97 and 194 would be almost twice as much. So that's how we did when we have the molecular formula. The empirical formula is going to stay to this. Is going to be this number, and the molecular formula, the real formula is the molecular formula is going to be this. So So you got that? So it's not so when I will help you if you have to do some problems like this, but it's not so hard. We just have to go through the steps that they give us. So let's look on, see what else we have here. Okay, let's do the review questions really quick. I think I have the review questions. Let's see. Maybe I didn't have them listed here. Let's see. Oh, section review. See if we have this. This is it. Calculate the percent composition of the following compounds: benzene C6H6. So let me show you how I did these. So let's look at my work here. It's not going to be that hard, but okay, sorry. Calculate the percent here. So what I did here, hope you can see here. I hope I'm not moving too much. So what we did, we have C6H6. So what we have to do to calculate the percent composition, we have to have 6, and then we find how much the weight is by the molar mass, which would be 12.01, because that's what carbon is. When we look it up on our periodic table, the weight is 2.01. We times that by 6, so we get 24.06 with gram per mole for carbon. Now, as for hydrogen 6, so we do 6 times hydrogen, which we did. 6 times hydrogen is 0.01 times 6, so we get times that by 6, and we get 6.4048, and we add those. As we add those to the total, we get 30.100 grams per mole for the total. Okay, but if you're going to get down to the sig figs, you're going to have to make it smaller, because 1, 2, 3, 4. We have 4 sig figs in there, so we have 1, 2, 3, 4, 5. So we're going to have to round it to, basically round it to 30.11 sig figs. Anyway, I didn't do that. So anyway, that's going to be the calculate the percent composition there, as we went to the next to find the percent. The next time finding the percent is, here's how we found the percent. So we ended up 24.06 over 30.1, because let's see, basically we know, okay, let's see, over 30.1. This one was 30.1. That's the total. So that when 24 is what percent of 30.1 is 4/5, or 4/5 is 0.80. So 80%. 80% is going to be how much carbon we have. 80% is carbon. See how I did that? I just took the 24.06 over the percent would be the total, just like the girls and the boys as we did. 24 over 30, and we get 80%. And so the hydrogen is the same way. We do 6.04 over 30, over the 30 here, and it's like 1/5. So it comes to 1/5 approximately, which is 1/5 is 20%. 20%, of course, 80 and 20 equal 100%. So there's 80% carbon and 20% hydrogen in that one. Okay. So let's go on to the next one here. The next one, let's see. Oh, the B. This is the B. We're going to find the percentage again. So this time we have, let's look at the number here. Oh, we have rubbing alcohol, which is the formula here. Let me show you the formula here. Is right here. Is 3 carbons, 8 hydrogens, and 1 oxygen. So that's what I did. So here I did 3 times the mole, which is 12, and we did 8 times the mole of so 3 times 12, and then we went 3 times 12 here would be 3603 times that. 8 times 1.08, that's the grams per mole, is 8, and 1 times 16, because we only have 1 oxygen, is basically, let's see, did I say 1 times oxygen? Oh, yeah. I don't know why I put 32 there. So 1 gram or 1 mole. Oh, 1 times 16. That should have been 16. So this is going to be a little bit. So we're going to do that over because I don't think I did that totally right, because I think we made a mistake. We 16 here. So anyway, let's go on to the next one and finding your percentages. You kind of got the gist of it anyway. Number 2 says if you have a sample of vitamin C that contains, here, let's do it here. If you have a sample of vitamin C, ascorbic acid contains this many grams, this many grams, this many, calculate the percent. So basically this is pretty easy, because to calculate the percent in this way is like this. It's very easy now. So you take 0.164 divided by the total, which is 4 grams, and then we'll get that answer is 0.41, and that would be 41% of the, so we're calculating, what they want to know is calculate the vitamins, the C, which is the composite, calculate the percent composition of vitamin C. So you do each one that way, which is pretty easy. The last one is this question here. Hydrogen peroxide used as a disinfectant bleach, rocket fuel, is 5.93% hydrogen, 94.07% oxygen, has a molar mass of 34.02 grams mole. Find the empirical and molecular formula. So this one's a little bit harder one to do, but see, basically going through the steps. So we have 49 and 94.07 oxygen, right? And so here's the sample of 100 grams. We take 100 grams, so then we have 5.93 grams and 94.07 grams. We just change it to grams. And then we divide it by the least number, which you divide 5.93 by the least number, which is what of molar mass would be 1.08. And that's going to be 5.88 moles of hydrogen. And then we divided 94.07 by the molar mass, which was 16 in oxygen. And so we get 5.008 moles oxygen. So that's the next. Now we're going to divide it by the smallest number. And when we divide it by the smallest number, which is 5.88, they're both 5.88, so they're the same number. We divide it by the number, and we get 1 and 1. So to write the formula, just 1 and 1, we get, write the formula is H and 0, just 1, 1. That's the empirical formula. So now, though, we have the empirical formula right here, HO. HO is the empirical formula, because look at it, just 1 and 1. And so now we want to look down to find the molecular. We as we add these together, the 1 and the 16, we get 17.08, right? And so 17.1 grams is what we round it to. So 17 divided by 34, because we said we have 34 in the question. We have 34.02, so we divide 17 by 34, and so we are going to get 17 divided by 34, approximately 2. So the molecular formula is really going to be 2 times this, so H2 and O2 is the molecular formula. The regular formula is just HO, and the other one is H2O2. So you just have to go through those steps. So that's the end of this chapter, and if you have these problems again, I will help you.